This is the Crypto Hipster podcast. This is not a traditional interview show. These are perspective driven conversations with founders, builders, and independent creators shaping what comes next. We go beyond headlines, beyond hype, and beyond price to explore ownership, freedom, and opportunity in the digital economy, where builders talk freedom, not price. We're moving into a world where everything can be verified, where content can be traced, authenticated, and proven. Open Origins is building infrastructure to make that possible. But that raises a deeper question. If you can prove something is authentic, does that actually create trust? So my first question is, if the input is wrong,
Hmm.
does your system just make the lie permanent?
Hmm. I mean, it's a good question. And it depends on your definition of wrong, right? We've had propaganda before we had generative AI, right? Propaganda that relied on factually true photos, for example, right? But just taken in a very interesting narrative angle. Um, those lended credence to the propaganda. They didn't make the propaganda by itself, right? So the way I see my technology is as a way to affirm that an event actually occurred without making any claims about the narrative that surrounds it. Right. So I can take a photo of someone running away from a building, and someone can use that to say that person was a thief and they're running away. Someone else could say, no, there was a fire and they were running away. I'm not going to make any claims about which story is real. All I'll say is that my technology proves that that person was actually running away.
Got it. So where does your data come from?
There's two ways that we authenticate content. One is for historical content, and one is for content that is being taken now. So real-time capture. For the real-time capture, we have an SDK that can be embedded as part of applications on both iOS and Android, as well as on some DSLR cameras. Um, and what that does is effectively, first of all, prove that this phone is a real device being held in someone's hand and not an emulator. It proves that the cameras at the back are real cameras, not emulated USB devices, and that as you're taking the photo, that there is a real 3D scene in front of the camera. Because if you didn't have that depth information, you could just fake the whole system by taking a photo, editing it, and taking a photo of a screen, right? So once we have all of that proof information and we collect a lot more sensor data, we have a very strong guarantee that this photo was actually taken at this time and place using this camera, using this lens. Right? So that's one way we authenticate content. The other is for historical content, right? So if a piece of content was captured 20 years ago, obviously we were not around to authenticate it, but that content is stored in an archive, let's say in a media archive. There we have this process called anchoring, where we go through this media archives historical logs, and we try to establish confidence in the timestamp associated with each media file. So let's say a piece of footage came to be from 2008 and it's a speech of Obama. We corroborate that with other data points within the archive. So maybe they have a logging service, maybe they have a media compression service. Go through all those logs and we corroborate. Again, this service saw it in 2009, this service saw it in 2010. Combining all of that, we can be fairly sure that this file existed in this form before 2010. And we know that by 2010, AI wasn't sophisticated enough to create these fake photos from scratch. So that gives us a high degree of confidence that this is a real piece of footage.
So your SDK captures the information from media file. Like who verifies those media files are correct? Because you said that you don't verify the story, but how do you know that information your SDK is capturing is actually the truth?
Yeah. So at its core, there is a process called remote attestation. which is basically that, any iPhone made in the last 10 years, any Android phone made in the last 8 years, has a hardware security chip. Right? This is where things like your Face ID data are stored. Right? And as far as we know, no one has compromised it. And if someone has compromised it, they basically own the keys to the Apple empire. Right? So that's the root of trust. When we do remote attestation, we're making sure that our code is running as expected on a real iPhone, right? And we know what our code does, and therefore we can validate what it is sending to us. Right? So to break the system, you would have to break Apple's encryption system.
Right. So if the starting point of the data is wrong, then what happens? Anything?
What do you mean by starting point of the data is wrong?
Where your SDK is capturing it from?
We've got bigger things to worry about.
Yeah, that makes sense. So how does your system protect the truth then, or do you preserve errors perfectly?
Yeah, so the way we work, there's two ways you can deal with a deepfake, right? You can either say, I'm going to make a deepfake detector. You give me a video, and my AI will try to figure out if this was created by AI and give you a yes or a no or a confidence percentage. We don't do that, right? We capture new content and we anchor historical content. If our SDK was not involved in the creation of a photo or a video, we don't make any claims about it. You give me a random footage from Twitter that our SDK hasn't seen, I don't make any claims about it. I don't know where it came from. But if it was captured from our SDK, we give you 100% confidence. We're saying this is for sure real and captured here, right? So we're trying to give a very strong binary answer here.
So I understand the imaging data. I understand the device data. I'm concerned about the historical data, right?
Yes.
So say the bad data goes in your system. Are you just locking in the bad data?
That's a good question, right? And it's good to point out that there is a subtle difference in the guarantee we're giving between the SDK and the historical data. In the SDK, we are giving you a guarantee that those pixels are real. In the historical data, we're not, right? Because we don't know what happened to that piece of footage before it arrived in the archive. What we're saying is that it has not been modified since it got to the archive, right? So this piece of footage, that Obama clip that I was talking about, has not been modified since 2010, and therefore is not created by Gen AI, but it could have been photoshopped for all we know, right? It could have been gone through compression, through filters, through whatever. We can't make any claims about that, right? So it's a different guarantee there. And we're very explicit about the two differences. Like if you go to our portal, we will show you where we sourced it from and what guarantees we're giving exactly. We'll say pixel verified, or we'll say provenance available, and we'll point you to the archive where we got it from.
So my question is, what qualifies as a trusted source? Like, why do you choose your sources, and why do you say that they're trusted or not? What's your qualification there?
Yeah, there's a couple of things. One is we primarily work with large news media organizations, but that's not to say that we take their word for what's in their archives. And this is where that corroboration comes in, right? So uh, I'm not going to use any names, but let's say there's a news organization A, and they have an archive, and the clip says in its EXIF data that it is from 2008. That's not enough proof for our system. Our system is going to require that there are third-party systems, let's say a Microsoft compression service or a logs.io logging service that corroborates those timestamps, right? So that if that news agency wanted to fool us, they would have to not just fake the EXIF data, which is easy, but also trick Microsoft's compression service and logging service, right? And that would effectively mean compromising those massive companies as well.
So is your platform, is it really decentralized, or is it just anchored to specific authorities?
Is it anchored to, sorry, what was that?
Specific authorities, like Microsoft,
Oh, yeah, so currently we have a permission blockchain where we run some nodes, news organizations run some nodes, and some of our collaborators run some nodes. In the next about couple of months, we're going to expand that pool to allow anyone to host that node. And it's going to be running on a slightly unconventional blockchain in the sense that there is no blockchain, it's just Merkle trees being anchored one after another.
and have you, I'm assuming you've tested that out so far, and how has the testing been going, and what have you noticed have been some of the concern areas?
Yeah, I mean, the main reason why we moved away from a blockchain is because of the sheer amount of data that we're ingesting. Like we're ingesting petabytes of content, right? That's just not going to work with a blockchain. That's a linearly growing data structure. We need it to scale both in terms of how much data it can ingest, but also how many nodes we can have. Because in an ideal world, we would want every individual to be able to join as a node. And that's just not going to happen with a blockchain. So our new decentralized network, it's called Cambium. We're going to release a white paper soon. Um, Scales to millions of nodes, no problems. Its throughput increases proportional to the number of nodes, so we can actually keep increasing how much data we're ingesting by adding more nodes. The concerns are a couple fold. One is that it is a novel data structure, right? So things like smart contracts don't happen. Like it doesn't have a smart contract. It doesn't have a linear data structure where anyone can read the data, right? So everything works in the way of Merkle proofs. So you are storing a local proof showing that you've done the work, but someone will have to come to you and ask for it, right? So there's questions about data redundancy there. Uh, it's gonna be a whole white paper that will have to like detail so that people get exactly what guarantees we're able to give and what we're not able to give. So data redundancy is one of those things that we're actually like actively deciding to sacrifice in order to get the scalability that we need.
And have you tested this out? Have you stress tested this out, and what's been the result?
Yeah, it's been really good. We've tested it with up to like 1,000 nodes so far. We will want to push it to about 10,000 nodes before we release it to the wider public. Um, Throughput, scalability is all good. We're now doing testing with like chaos monkeys, try to take down the network and see how it performs.
Okay. So my concern is that, for all the people, all the blockchain lovers out there in the world, is your technology now going to make the future blockchain obsolete?
I think those are two very different purposes, right? The way I think of a blockchain is that it's like a public bulletin board, right? You post a transaction, the whole network sees it, anyone can go and read it. And there's definitely uses for that technology, right? Like if I want to declare something, a blockchain is great because anyone can go and verify what I've done. Um, but that's not what we're trying to do, right? What we're trying to do is give you the chance to prove your content to whoever you want to, right? So in our network, you'll commit a proof. It will be private to you. You can't fake it. The mathematics makes it so that you can't fake it, but you decide who gets to see it. Right? So the visibility is gated by you, and that is a completely different system. So a different tool for different problem.
So if I wanted to game your system,
Mhm.
right? Where would I go to do it?
I think there's a couple of interesting data points there, right? One is you could try to compromise the SDK, right? Find bugs in our implementation. I'm not saying that we're perfect. There might be bugs there, which is why we're open sourcing it as well, because we want people to find the bugs and report it to us. Um, the second place where you could try to game it is in misleading the audience, right? Like as you started this interview with, proving that the pixels are real is like a small part of the puzzle, right? Just because my piece of software gives it a green tick doesn't mean that you should trust the story, right? All you can trust is that the pixels are real. And, as we've seen in the history of propaganda, as we're seeing right now with all the wars and all the propaganda around it, um, the content does get faked, but many a times it's real content being intentionally misleading. The people are taking snippets of a conflict, or they're putting commentary that is just not true, or they're reusing content from, another war or a past era. All of that can still happen even with my technology.
That's why I left X.
Yeah, fair. Yeah, I don't post that either.
So at what point then do you think your system is the weakest?
User interface, right? Because that's where the most amount of fungibility is. And one of the issues is also that it is very hard to train people to think of provenance and not truth, right? When people see a tick mark, they instantly retrust all of it. When what they need to be trusting is all I'm saying is that the pixels are real, right? That doesn't give you a free pass to turn off your critical brain. You need to have your critical brain still on.
So I was thinking before we started speaking today that your vulnerability was at the verification layer, but it seems to me like it's before that.
What do you mean?
Like it was at least with the historical, was at the weakest point. The vulnerability was at the historic. But I'm thinking like because of the story, because of the narratives, it happens long before the verification layer.
I don't think to think of like a realistic attack. I don't think that's where I would like if I'm an adversary and I want to spread a fake piece of information. I don't think I'm going to premeditate an attack 5 years in advance, right? Like that is how you would have to fool my system. That's not realistically how attacks happen because stories change too quickly. So what I would actually do is I would create a bunch of real photos in the sense that the pixels are real, the metadata is real, all of that is real, but shoot them in an intentionally misleading way, right? Crop them up, chop them up in such a way that it is misleading, publish it, still get the green tick mark, and get your propaganda across, right? And this is why the propaganda, the news angle is actually trickier than our other verticals. Like we work a lot in insurance. There, it's a much cleaner story, right? In insurance, what we're trying to do is, you've got an insurer, you get into a car accident, you need to take photos of the damage to your car, and you need to send it to your insurer, right? That system has worked perfectly for about 20 years, but now what people are doing are they're putting their cars into ChatGPT and asking it to dent it, and then filing a claim, right? So we're seeing a huge rise in these small claims fraud. In that situation, we're not trying to prevent propaganda. We're trying to prevent a very specific kind of financial fraud. And I feel a lot more comfortable there with our UI, with all of those things.
So in the case of the financial fraud,
Mhm.
proof creates trust.
Yeah, I think so. Yeah, because again, it's very constrained. The dimensions of the problem space are very, very well constrained. You are supposed to take photo of your car from the front. They know what your car is, they know the model and make. All we need to make sure is that the damage actually exists.
So you are solving trust. You're not just packaging trust, you're solving it.
Yeah, in that domain.
Okay. In the financial domain, but other domains you can't.
Just because the range of actors is so broad, right? If we can constrain the problem space, it becomes a solvable problem. But because the problem space is so broad, we don't even have a question to ask, right? Like, what is trust in this scenario, right? Is trust being able to prove what you're doing? Sure, then we've solved it, right? I have given you the tools. It's open source. Go use it. Take photos. Prove to anyone that you were actually in Argentina yesterday, right? That we have solved. But have we solved fake news on X? No. And that's not something we'll be able to do.
So now what happens if, say there's an incentive to lie at scale, to the people get incentivized to lie more than they are now, right? Does your system hold up to that or does it get overwhelmed?
Um, Again, we don't do detection, right? So I am not trying to tell you whether a random photo is real or not. Right? Either I know about that photo or I don't. Right? So it doesn't matter how many people are trying to lie because my system will just say, I have never seen this photo before, so I can't make any claims about it. But it will scale with the number of people who are trying to tell the truth. So if 1 million people are capturing the photo with our new blockchain system, we'll be able to support them.
So a piece of content, let's say, oh no, yeah, let's say a piece of content, let's say financial content or pixels or whatever, that content gets verified as authentic, which you can easily do, right? But
Mhm.
later, it somehow, through Amazon or through Apple Archives, whatever, it gets proven that it's false data, right? Do you do you go back and do you change that data, or does it just stay as false on your system forever?
What do you mean? How? I feel like the assumption in the question is wrong, right? So
Okay, okay,
the photo was taken. It was verified using the hardware security module. on your foot on your camera. That proof information was anchored to the blockchain. After that, what are you going to do to falsify that photo? Two different guarantees, right? One is that on the SDK side, it is a hard cryptographic guarantee on the validity of the pixels and the audio. Right? Like we are giving you 100% guarantee that nothing has been modified. What you're seeing on the screen was what the camera captured on that date and on that place, right? The guarantee with historical content is different. The guarantee there is that we went into an archive and we found it in this form from this creator and verified with these timestamps from Microsoft logs, etc., etc. Right? But we're not making any claims about what happened between the camera and the archive. Right? So think of it like this is the difference between authenticity and provenance. SDK gives you authenticity, the anchoring gives you provenance for historical content. Right? And we need both because we still need to be able to trust what happened in the past, even when we have 100% adoption of Open Origins SDK for everything.
Got it. So the real problem isn't verification; it's everything that comes before it.
Yeah, and I think that's why it's really important that we need to like spread the adoption of these secure camera technologies, right? The longer we don't have this be the default, the more historical content is going to be created without provenance, without authenticity. And it's going to get harder and harder as AI gets more sophisticated. Yeah. The way I see it, the core problem is adoption. It's not the verification, it's not the authenticity, it is adoption. We need that SDK embedded in every place that people are taking photos.
And how do you get there? Say, you know, people, everybody claims to have 100 million users, and everybody I've talked to in the past 4 years, I want to get 100 million users. I want 100 million users. How can you get to 100 million? If I'm looking back at a year from now, and you and I are talking again a year from now, what will you have done to get that 100 million users?
I'm not going for 100 million users. We're an enterprise company, right? We work with news organizations, we work with insurance companies. So we're going top down, right? We want it to be embedded within Instagram so that when you're taking photos on Instagram, it's getting in the background authenticated using Open Origins tech. I don't think it is a very good expansion strategy to go B2C on this. Like I can't expect people to use a different app on their phone every time they want to take a photo. I want the default option to be the authenticated one. Right? So my bet is on the enterprise side.
That requires you to be able to trust the enterprises and to trust and the enterprise, and people trust the enterprises.
Well, they already do, right? Like if you're posting your content on Instagram, you're already trusting them. What we're trying to do is make sure that we're keeping Instagram accountable by having an SDK that's actually authenticating new photos.
This system works if the starting point is honest, and which means the real problem is not verification. It's everything that comes before it.